But yeah, now we have Alton Byers. Great. Sorry for my mistake. And can you try?
Hi.
Okay. Yeah, we hear you. Yeah, we hear you.
Yeah, I'm here. Yeah, you have it already. It's pre-recorded. You said you would play it.
We should have a video. Yeah. Okay. Just consulting with the with the technician here. Okay. So we just launched the video.
Yeah.
Hi, this is Alton Byers from the University of Colorado, and today I would like to speak about climate change and glacier hazards in the high mountains and how we can integrate science and traditional knowledge for reduced impact and strengthened adaptive response. Now, to begin, we all know that we live in a changing mountain world. All we have to do is look at photographs taken in the 1950s of high mountain regions, such as in the Mount Everest area, and again, just a year ago. We can see what was a debris-covered glacier back in the 1950s is now a large and potentially dangerous glacial lake. Now, this is an example of repeat photography, and that is simply where you find the exact photo points of the early climber scientists in a region. Could be the Himalayas, could be the Andes, and you go back and replicate their photographs and then assess what the changes have been. Now, what I wanted to bring out was that when these early climber scientists back in the 30s, 40s, 50s were taking their photographs, actually their greatest concern was the return of the Little Ice Age. As we can see here, the Mer de Glace Glacier in the French Alps and the Mont Blanc Glacier Massif, drawn in the 1890s, where a glacier is shown as something demonic, as a dragon coming down out of the mountains and destroying villages. So glaciers have not always been loved as we do today. They have been feared at times in the past, especially during the Little Ice Age, during the 1600s and up to 1860 or so. Also, we tend to think that glacial lake outbursts, floods, and hazards are something that happened since the 1960s, when in fact they've been around with us for a long, long time. This is the Rafenthaler Ise, or lake and glacier in Austria, painted in 1601. This is the oldest known painting of a glacier that exists. And even then, we can see there was a lake, a glacial lake with icebergs. And this lake, in fact, flooded a number of times and destroyed villages downstream. So we've been dealing with glaciers and glacier hazards for quite some time now. What I'd like to do today is to look at several different types of glacier hazards, including glacial lake outburst floods. We'll look at landslide triggered floods, then take a look at earthquake triggered floods, and finally look at how we can reconstruct the history of floods using oral testimony or local histories with the latest in scientific techniques. So let's start with one that you are probably familiar with. Some of these others you probably are not that familiar with, but these are glacial lake outburst floods. And what we have here is a lake. It used to be a glacier, but since the 1960s, it has melted and receded so that the glacier terminus is now way back close to those white mountains, as opposed to being more in the foreground. This is the lake. In this case, the Imja Lake has about 90 million cubic meters of water held in by an unconsolidated terminal moraine, which was simply not designed to withstand the pressures of the hydrostatic pressure of all this water. Now, what it takes is a trigger, and a trigger could be an ice avalanche or a landslide into the lake that creates a surge wave that overtops the terminal moraine and unleashes millions of cubic meters of water downstream. This is a flood that happened in the Tamapokiri in Makalu-Burun National Park in 1998. You can see, you can imagine how much force was required to breach that huge terminal moraine. Here's another one that happened in 2017 in the Burun Valley. Again, even though this was a small glacial lake, it resulted in considerable downstream damage. So we can watch these changes occurring before our very eyes. Here is the Khumbu Glacier on the way up to the Everest Base Camp on the Nepal side back in 1956. I retook it again in 2007. You can see the formation of new glacial lakes, as well as lots of indication of glacier melting. And then just last year, here it is again. So we can see that these changes are happening quite rapidly and accelerating faster than we ever thought imaginable. And this, in fact, is probably a future glacial lake in the Mount Everest area. That's because the gradient of the glacier is quite low. It's less than 2 degrees. And that means that the water can pool and form a glacial lake, as we've seen in previous photographs. Okay, so that's the first. That's glacial lake outburst floods. Another type, however, that you may not be familiar with is end glacial conduit outburst floods. That just means end glacial in the glacier. Conduit is another word for caves, and that means that the flood originates within the glacier as opposed to from a lake. So what we have here is the Lhotse Glacier, for example, in the Mount Everest area of Nepal. This happens to have a slightly a larger gradient, greater than 2 degrees. So the water never has a chance to pool. It just flows off. But what's happening is the glacier itself is turning into something like a big piece of Swiss cheese. That is, it's riddled with caves, with ice caves throughout. And these are often connected to superficial meltwater ponds that you'll find as you walk along the glacier that can drain very, very rapidly, as we can see here. That's the same superficial pond, which drained in just one day. Now, that water was enough to trigger a flood from one of the conduits within the glacier itself. And here we have a photograph of the water bursting out of the glacier as opposed to coming from a glacial lake. Now, my informal survey of these types of floods in the Khumbu suggests that they are indeed increasing in frequency, certainly since the 2000s. Now, we were walking down this particular Lhotse Glacier when we actually were able to see and to film one of these outburst floods, which looks like this. You can see the water breaking through the glacier, through the ice lens that is holding the water in place. It's pooling, it's moving down, and the problem is it's heading straight for the village of Chukung, which is a tourist village downstream. So people down there were quite frightened. And even though it took us a couple of hours to get down to Chukung that day, the flood was still raging. Fortunately, the village was protected because gabions had been built the previous year after another one of these floods. So damage was actually quite minor. Now, these floods are actually, they really rarely make the news. You don't hear about them that much, but they do occur. They're not reported to the press, and they are causing considerable local damage in the region. Let's look at a third type of glacier. That's a landslide-induced glacier flood. You're probably familiar with this because of the recent flood in February 2021 in Uttarakhand in India. But this one happened in the Burun Valley in eastern Nepal, and this is in the beautiful Makalu Burun region and National Park. I love this photo because you can see the banana trees in the lower left, and yet 30 miles away as the crow flies, there is the fifth highest mountain in the world, Makalu, and Chamlang, that flat mountain off to the left. So tremendous diversity within a very short distance in this region. Now, we were in the Mount Everest area doing research on glaciers in 2017 when we heard that there was a glacial lake outburst flood in the Burun Valley, a GLOF. Now, the press always seems to report that lofts have happened whenever there is a flood, but we were able to take a helicopter over and do a quick survey to try and figure out where this flood may have originated. And it turns out, as we were flying up one of these glacial valleys, we came right upon the source, which was the Langmale Glacier. And you can see right here, I'll pause for a second. You can see this was the original terminal moraine that was breached by a flood. In this case, there happens to be a large deposition of debris, but somehow that was triggered. We weren't quite sure what the trigger was, but then later, as we were flying around, we saw all this debris on the snow, and we didn't know what we were looking at the time, but the cause of this particular flood was right here. It's that mountain right there, which is Saldim Peak. And in this case, what happened, a large portion of the mountain broke off. It broke off, it fell down onto the glacier, created a huge cloud dust, and then proceeded on down to fall into the lake, melting water as it went, and we had quite a large glacial lake outburst flood. These seem to be becoming increasingly more frequent, again, because of changes in permafrost. So what I call the cryospheric glue that has held these rocks and these mountains together for millennia is now changing and weakening in some cases, so that we are seeing more of these types of events. Again, you can see how the rock broke off, fell down, huge masses of icebergs were blown for a couple of kilometers downriver. Everything was coated in white dust, and fortunately, there was very little infrastructure downstream. Otherwise, this would have been not just an event, but it would have been a glacier hazard. A group of climbers was in the area at the time, and let's just take a quick look at what the flood looked like. You can see here it is, right at its peak. They were able to film this flood, carrying down debris, carrying down trees. It's what we call a hyper-concentrated slurry glacier flood. You can see that this is so filled with sediment, it looks sort of like a concrete, flowing concrete. Also, this took away a couple of tourist structures. There's a lodge that I've stayed at many times throughout the years. Fortunately, the temples were spared, but this lodge floated away. And so you can see that considerable damage was done. What's interesting is that we think that this same process, however, caused the Setikosi flood of May 2012. That is a massive breakage off from the mountain that created a huge dust cloud, proceeded on down. In this case, it was triggered the flood from a landslide dammed lake, and then created enormous problems downstream. Some 70 people died downstream during this event. So they're quite hazardous. And possibly the Uttarakhand glacier flood of the 7th of February had similar type triggers. So this is another one that doesn't get a whole lot of press, but is becoming more and more common. Finally, let's look at the impacts of the 2015 earthquake on glacial lake stability. Of course, this had a tremendous impact on Nepal. Some 9,000 people lost their lives, and we were sent over by USAID immediately afterwards to look at what the impacts of the earthquake may have been on 3 glacial lakes. Imja, the center is Shoropa, and then on Tulagi. These are 3 potentially dangerous glacial lakes as identified by the Department of Hydrology and Meteorology, as well as ICIMAD, the International Center for Integrated Mountain Development. We wanted to go to the field to see what the impacts may have been. And it took quite a while to get to each of these lakes, and in fact took about a month to do the field survey of each lake. Now, at the time, there were 3 different methods of assessing impacts of the earthquake on glacial lakes. One was by remote sensing, and this was by a study that was led by Jeff Cargill at Arizona State University, who with a team of scientists looked at remote sensing on a daily basis. And if they saw things of potential danger or potential interest to the government of Nepal, like a landslide dammed river that formed a lake that could be dangerous later, they would inform the government. They concluded that there were no glacial lake outburst floods as a result of the earthquake. A second was a reconnaissance, the helicopter reconnaissance of the Department of Hydrology and Meteorology. They visited a number of glacial lakes and concluded that there was no imminent danger of a flood as a result of the earthquake, okay, based on a helicopter flyover. And then there was our study, which I call a rapid reconnaissance, but also included consultations with local people, whom, as you can imagine, were quite distressed over not only the earthquake and the damage that had done, the lives that had been lost, but the fact that they were living below a massive glacial lake that could possibly burst. So they were quite concerned and very interested in the results of our research. Now, in fact, what we found, there was a glacial lake outburst flood on the day of the earthquake, and that was the Langmoshe that occurred in 1985, which launched a massive flood that destroyed bridges for 100 kilometers downstream and killed 5 people. And then again, on 2015, the day of the earthquake. Now, this second flood was quite a bit smaller, but we think had the same triggers, and that was ice avalanches into the lake. Happened again in 2017. The downstream damage was not as bad as in 1985, but this has taken some time later. You can see people have already adapted by building higher bridges and also building gabions or rock-filled cages along the side of the river to divert flood flow in the future. Again, we only knew this because we talked to local people. These are things you really can't see from the air, from remote sensing, or even from a helicopter. And in other lakes that we surveyed, we talked to local people. They were able to show us things that we probably would have missed, such as this massive crack along the fragile terminal moraine holding in this lake. They could also identify things such as loss of land through landslides, boulders moving, other indicators of damage to the glacial lake. So including local people in your study, we think is really very important. And finally, in remote areas, it's often difficult to know what has been the occurrence of floods in the region in contemporary times. And here is an example of a study we did in 2019, right before COVID, which was reconstructing the history of glacial lake floods in the Kanchenjunga region. Now, what we knew before we went there was that in 1980, there had indeed been a glacial lake outburst flood from Nangama Lake. The trigger was most likely an ice avalanche, caused a surge wave, which breached the terminal moraine, caused pretty extensive damage downstream, including a landslide or debris blockage that blocked the Cheche Pokoti and formed a lake, which you can see to this day. However, this was the only glacial lake outburst flood that has been recorded in the scientific literature, which we felt was sort of odd in an area that is as dynamic as the Kanchenjunga region. Surely there would have been more. So what we did is, on the way to the Kanchenjunga Glacier, we would interview local people, especially older people who had a memory of the region for decades. And in fact, they said that not only was there just one glacial lake outburst flood, but they could remember at least 8 different floods, including one that happened in 1921. That's the number 8 circle. That must have been huge if it's still remembered to this day. Now, once we had this evidence based on oral testimony, we went back and our remote sensor was able to show before and after photos of each of these lakes, and now not only show that yes, a glacial lake had occurred, but also assign dates to them. So this is an example of blending traditional knowledge, local knowledge with scientific techniques to get a better understanding of what is happening. Okay. In summary, what is the problem? We've got high mountain regions have entered an era of accelerated glacier and high mountain hazards. Again, it's a hazard if there are people or infrastructure downstream. Otherwise, it's either not known or called an event, and most of these remain poorly understood. So what are the prospective solutions? Well, I have a little equation that I call where you combine interdisciplinary research with participatory approaches and involving local people, plus local knowledge. You combine all three, and we have better risk reduction options and understandings of the problem. So, for example, when do you lower a lake that's dangerous? Or when is it more appropriate to install an early warning system? When could zoning be more appropriate, and or disaster training for local people? So in other words, what we're saying is that in addition to the field science that is being conducted in the Himalayas and elsewhere in the high mountain world, you can get added benefit by involving local people in the research, by involving local scientists, or promoting scientist to scientist exchange and collaboration. So what you end up with is a combination of scientists to people sharing, scientists to scientists, and also better ensuring ways to make the data accessible for policymakers. That's often a challenge in today's world. We have research that appears in peer-reviewed papers, but it never quite makes it to the decision maker or the policy maker, and this seems to facilitate that process. Now, what's happening is that by working with local people, you are and sharing information, you're giving them the option of making better informed decisions based on scientific data. Now, another is to recognize that local adaptations are already being developed, and perhaps we need to think of incentives that encourage these to continue. So, for example, in this presentation, we've seen that people are building more and more gabions throughout high mountain regions down along the river sides in order to divert potential floodwaters away from very valuable infrastructure. We have also seen bridges are being built higher than they were before, and people are actually practicing an informal type of zoning. They're no longer building on floodplains. So that hotel that you saw floating away earlier has been now rebuilt on higher ground in the same region. So people already are adapting to climate change. It's something we need to recognize and also to encourage. Promotion of international collaboration and exchange is also important. We once took a group of not only Asian or Himalayan scientists from China and Pakistan, Bhutan, Nepal, but also Andean engineers and glacial lake experts up to Imja Lake to exchange experiences in dealing with glacial lakes, which was a very productive exercise, not only because it promoted scientist to scientist exchange, but because local people came along. It was an opportunity for them to share their concerns and ask questions of scientists from all over the world. And finally, promotion of high mountain climate change education and local global connections will be very important, not only at the undergraduate level, but also at the graduate level, where a very cost-effective way of increasing our understanding of climate change and glacier hazards is to help support research, help support graduate students from around the world who can do this research that can answer the questions that we have. Finally, I think it's important to incorporate cryospheric hazards into large engineering project design, because often large hydropower projects, as we've seen recently in the Uttarakhand example in the Nanda Devi region, these have been built without considering upstream glacial lakes and the potential damage of glacial lakes and potential glacial lake outburst floods. And not just in this case in Nepal, but also from lakes originating in Tibet. So transboundary cooperation is going to be very important as well. And finally, poorly designed engineering projects are only going to exacerbate the problems created by a changing high mountain world. So they should be considered much more in terms of what is a good project, what is a needed project. So with that, I'd like to say thank you very much. I hope that you have learned something about some of the glacial lake hazards that you are aware of and some that you may not be aware of, and also the importance of using not only scientific research, but also including local people and their knowledge and wisdom of these processes. Thanks very much.